All right. Hello, everyone. So yeah, as he said, I'm Chris Truncer. This talk is isolated to constrained language mode, living within the confines, like also mentioned. I'm primarily going to be talking about PowerShell, and what everyone probably knows PowerShell is what it's called, or not really the boot process, but like where do they try to protect the system? And this is for kernel mode code integrity and user mode code integrity. And right over here is what constrained language mode is trying to like help protect. So what does constrained language mode mean? So like we said, it's largely used to block dangerous data types. So if we can just arbitrarily invoke Windows APIs and use that to just inject shellcode into memory, like Beacon or Mimikatz, or do anything, interact with dangerous or protected processes like LSASS, then that's not something that you probably really want to be able to do or have anyone just arbitrarily be able to do. So it looks to block different tasks or things that you can do that it would consider dangerous. If you build a PowerShell script using pure PowerShell, so we're not invoking any sort of .NET data types or anything like that, then your code probably will work. So let's kind of take a quick look. Constrained language mode data types. So the way that this works is constrained language mode introduces whitelisted data types. So this isn't like they only blacklist certain different types of data that you can interact with. It's largely, if you aren't using an allowed data type, it's completely blocked and you're getting an error. And so you would see something like this. So, oh gosh, sorry, that's a little bit hard to see. So what that says is if you're trying to run either a script or a tool or some sort of commandlet that it uses a restricted data type, it's going to say cannot invoke method. Method invocation is supported only in core types of this language mode, meaning that it's only allowed in full language mode. All right, so the next question is, okay, how can we obviously test what's allowed? Well, the first thing you can do is go to MSDN, look at their documentation. The next thing that you can do is test it and figure out what MSDN is missing in their documentation and actually find the real data types that you can use. So PowerShell Pro Matt Graeber, I like this because I don't think you can basically give a PowerShell talk today about anything in the world without somehow referencing Matt Graeber and the work that he's done, because he's done a lot of awesome stuff. And so, of course, Matt also wrote really a script, but really more like a one-liner that can enumerate different data types that are actually allowed in constrained language mode. So hint, there may be some differences. So what are the big things that are or aren't allowed? Well, COM objects are supposed to be blocked. If you use Add-Type in your PowerShell code, that commandlet is completely blocked. Different PowerShell classes are blocked. Type conversion isn't allowed unless it's using an approved whitelisted data type. Dot sourcing your code is not allowed. And again, it comes back to if you're using anything with .NET, only approved .NET data types are allowed. So this is a giant list, but this is actually all that's listed on MSDN's page for constrained language mode on what's allowed. So you have some stuff that makes sense, right? You have like bool, so you can do like basic true, false kind of determinations. You have different integers that are allowed. You can create a PS credential object in case you're trying to authenticate to some sort of remote resource that requires a PS credential. Different integers. So there's different types of data types that are allowed. So obviously that's a lot, but the question is then, is that all inclusive? So MSDN states that that is like the end-all be-all list of data that's allowed. So again, we should kind of follow a something trust but validate sort of process. So let's kind of look into this. Like I mentioned, Matt Graeber did release or not release, but he just publicized a one-liner that captures the different data types that are allowed. And this is basically what you're looking at. And so it's just this reference to assembly, get type, system management, automation, core types. And then we're looking at just to pull this sort of information back right here, the items, non-public static. And you can all read the command, but this is what we'll actually run to enumerate what data types are allowed. So I cut it off. This is not the entire list because it would have been too big of a screenshot, even though this is already fairly large. But you can see that there's some of the same information, right? So we have integers. Again, we have different bools. We have some sim classes so that we can also interact with that are listed here. There's a variety of just different data types that are going to be listed here. A lot of them are going to be the same, but some of them may be some new additions that aren't listed in MSDN's documentation. You know, it's funny, I was talking to a couple different friends of mine that are also MVPs, and they stated that Microsoft may have actually kind of gotten rid of their documentation staff, and that it's up to each project that is in charge of certain aspects of MSDN, or like whatever they're doing within Microsoft, it largely relies on them to write their own documentation for that. Now, if that's incorrect, someone tell me, but that's what I was told. And so hopefully we're going to start getting better documented information that we can look at when you just want to try to see what is the current status of whatever we're looking for with Microsoft products. Sorry. So here's an example, and we'll skip to the next one just to get through this. So here's an example of what I'm doing is I'm running get credential to capture credential information, so that's a username and password. And so we can see that that's a PS credential object right here. Now here's another thing that we're doing is we're creating a new SIM session with a remote system, and I'm passing the creds that we just created with get credential. And the session objects are DCOM session options. Like that's the data type that's listed if you actually look at and try to inspect through PowerShell what the data type is. In this case, you can see right here, it is a SIM session that we're creating. That's the data type that's allowed. And this is all done within constrained language mode. So some of these were listed right on MSDN's documentation. But like the SIM session information, I don't know if it actually falls under what Microsoft lists as their management class here. And I tried asking other individuals if that is where it somehow lies under that class. And I didn't really get a great answer. So I'm interested, and if anyone knows the answer, I would love to talk with you after as well, because just different things that you can seem to do in constrained language mode, again, aren't completely documented. All right, so long story short, there's still a lot of different data types that are allowed, what you can do and interact with in constrained language mode. The trick is to ensure that you're interacting or using an allowed data type before you start developing different tools, or as you run into issues, try to figure out an alternate way to do whatever it is you're trying to do without interacting with that restricted data type. The easiest way to do it is to check MSDN docs. If you can figure out whatever you're trying to do is allowed, perfect. If you can use Matt Graeber's one-liner, or really, honestly, the way that I develop a lot of code that is in constrained language mode is I'm just enforcing constrained language mode and then testing and writing code until something errors out, and then I'm trying to figure out, okay, how can I do this a different way? So again, the easiest way to enforce constrained language mode is to set it yourself. And so this is that host.runspace.language mode that I referenced earlier. You can just run this within PowerShell and set it to constrained language mode, and that essentially that session that you're interacting with from then on, unless you were to change this, actually is using constrained language mode versus full language mode. So here's an example. Right now, we're in full language mode, as you can hopefully somewhat see right here, and we're trying to do this, figure out the square root of 9. And so that's allowed, we're getting 3 is returned. Well here, I'm now changing that to host run space language mode equals the constrained language. Sorry about the coloring again on this. And if you then try to run that same math square root command, essentially, to determine what's the square root of 9, that's actually not using an allowed data type in constrained language mode, and square root, which is, you would think, fairly easy, not benign, or I mean, is benign, is restricted and is not allowed at all. So CLM, this is basically the biggest limitation for attackers on CLM protected systems. If an attacker can't weaponize any of their PowerShell scripts because they all somewhat either use restricted data types or restricted or different commandlets that use restricted data types, is going to be blocked. So it's not like application whitelisting where an attacker could then try to figure out, okay, how can I administer their application whitelisting solution or system, whatever it is that they're using, and whitelist it. It's just outright blocked. So it just won't work within constrained language mode unless the attacker actually goes back and tries to figure out how to rewrite their tools to do something that is allowed. All right, so let's kind of translate all this. That was a lot of information thrown back at you. What works and what doesn't. So let's run some quick tests. So again, we saw square root. We'll see it again. We'll look at base 64 encoding. And then let's look at shellcode injection, what an attacker may try to do to compromise the system that they're on. or compromise the system that they're trying to get a beacon or interpreter running. Let me get this up. All right, so what we have here is this is just showing host run space.language mode. Is right now we're in full language mode. So this is again doing that math, trying to figure out square root. This is kind of a validation test to make sure that we are in that. And it does work. We do get 3 returned back to us. And so this is where I am trying to now perform base64 encoding. So what this says is just 40 north and BSidesAugusta, and we're trying to get the bytes of that string. And once we get the bytes, we are converting to a base64 string, and we can see that that's our base64 encoded result. And so this is all allowed, like you would expect in full language mode, just normal PowerShell. What I'm going to do is now change it into host run space language mode, and we're changing it into constrained language. And so now we're going to kind of try to conduct the same tests. We're going to do the same thing here with math again to try to find the square root. We can see that that is blocked. That's not allowed. Well, what if we want to just base64 encode a string? So we have to start getting the bytes there and then encode it, but that is also completely blocked. Sorry, that went kind of fast, but that was blocked there. And so finally, what this payload.ps1 is I don't know if anyone's used Cobalt Strike, similar to Interpreter. This is basically an output for a PowerShell-based stager. So we run that PowerShell code, and then we would get a beacon on our system. So same thing as if you were using MSF Venom's PowerShell output to get Interpreter on your system. So if we try to / call that, it's going to be blocked for multiple reasons, to be honest. But it's just completely not allowed. So constrained language mode is really good for locking down systems and starting to restrict some of the different features that attackers try to use to compromise either a local system or a remote system. Okay. All right, so next up, what can we do, what works, and what doesn't? So with everything that's kind of blocked, it's kind of outright from using constrained language mode, what's left? Well, a lot of people, one of the things that you can do that's awesome in PowerShell is largely use C# within any sort of PowerShell code that you want and run C# code within it. Well, if you're thinking of trying to convert your C# code and using it in PowerShell, don't, because it's highly unlikely that it's going to work. But the interesting thing is if you're just trying to administer a computer and like use either built-in commandlets or just pure PowerShell to do something, that's probably going to work, right? Because like we said in the beginning, the whole point of constrained language mode is to restrict sensitive data types, but allow user or administrators to still administer their computers. So one of the things that obviously I've worked on Veil before, antivirus is always kind of an interesting thing for myself and just attackers in general to look at, is antivirus administration. You can do that right now currently with PowerShell. So one of the interesting things that I really like are Microsoft's attack surface reduction rules. Has anyone heard of ASR, attack surface reduction rules? Awesome. You should come grab one of these books. I have to give these away, so make your way down and grab one, whatever you'd like. Attack surface reduction rules are really are really kind of cool, I think, because the only downside to it is it's only allowed on like Windows 10 or Server 2016. But you can do enforce a lot of unique rules, such as you can prevent processes from being spawned on a system that were initiated via PSExec or WMI. You can also prevent macros from running, or prevent like Office documents from spawning, or excuse me, Office processes from spawning child processes, right? Like, why would Microsoft Word need to spawn PowerShell on a system or command.exe? There's probably no legitimate reason that that's really allowed. Yes, sir. It's going to depend upon what you're doing. So now, if we were talking device guard and Windows Defender application control, my answer would outright just be no, because it doesn't allow you to, you assign where you give trust, and so that Windows or device guard enforces trusted rules on both executables, but also libraries from being loaded. Now, if you are able to write code that loads different DLLs or conducts the actions that you want to do, basically kind of replace the DLL in a constrained language mode compliant manner, then that would work. But the only thing with, and I think I talked about in a couple slides, constrained language mode is useful to stop PowerShell, but if you don't enforce constrained language mode in addition to application whitelisting, then it's kind of not super useful, because let's say I wrote a malicious PowerShell code, just like you were kind of talking about, and you wrote it in C# and you have PowerShell run that. Well, let's say constrained language mode is protecting a system, but application whitelisting isn't. Well, in that case, I would just take that C# code, compile it to a library or into a PE, an executable, and then just run it that way, because constrained language mode doesn't protect against executables from running on the system. It's only PowerShell. So yes. Yeah, well, so.
I'm sorry, could you repeat the question just for the recording?
Yeah, sorry. So they're asking if constrained language mode only protects PowerShell.exe or PowerShell.ise, or is there another way that you can maybe get around it? So the issue, it's going to be protecting it on the system.management.automation DLL. So if you can't, basically if you have to, it's not restricted to just the exe itself, because PowerShell itself isn't PowerShell.exe. It's the system.management.automation DLL that PowerShell.exe loads. So it's within that DLL essentially. Anytime that that's loaded and you're trying to run PowerShell code, that is what's protected. But again, if you're so the question was, if you load system.management.automation DLL, and would that still be loaded in constrained language mode? The answer is it depends. Like, how is constrained language mode enforced on your environment? If you're doing kind of what we did back here, where we're just a couple slides back, where we're just setting it while having PowerShell started, then no, because you're not in that session of PowerShell essentially. You're loading it in another program. But if you're enforcing constrained language mode through some sort of GPO or something like that, then it should be protected at that point. Okay, yes? I can't speak a ton to advanced threat protection, so I don't want to give bad information. I would believe that it should. But I don't 100% know that answer, so I just don't want to give you the wrong answer. Any other questions? Oh, sorry. So the question was, how does that actually relate to Microsoft ATP, Advanced Threat Protection? Does that get reported into them? And like you mentioned, I believe it would, but I don't know the answer for 100% certainty. All right, so kind of going back to this, antivirus administration. So there are ASR rules which can do really cool rules that aren't enabled by default and are only allowed to run on Windows 10 or Server 2016. And so like I mentioned, you can completely stop processes, from being spawned via WMI or gosh, I'm drawing a blank on what the other one was now. Anyways, there's a bunch of different rules that are out there, and you can set the configurations across, across your entire domain, however you want. So my thought is, well, if we can enable these rules using PowerShell, and we can do this in constrained language mode, we can also likely disable the rules. Well, if we can also set configurations for antivirus in constrained language mode, an attacker can probably do the inverse operation. So that's probably useful from an attacker's perspective, right? So let's look at this. So there's a commandlet called get mp preference. What this commandlet does is it obtains the antivirus configuration of the system that we're targeting. The interesting thing is you can run this commandlet both locally on your Windows 10 system. You can also run it remotely on a system that you're targeting. So what does it use for authentication? Well, we're using sim sessions. Well, the interesting thing was, we just looked at the, kind of the very beginning of this talk, is what can we actually do in CLM mode, constrained language mode, is we can create sim sessions. That is allowed within constrained language mode. So let's kind of give that a shot and see what it looks like. I have a video we'll show in just a second, but right now, this is what you get if you run get MP preference on your local system. Is there's a whole bunch of different information about antivirus right here, but then some of the more interesting ones may be the exclusion extension. Which extensions are we excluding from having antivirus look at? What path are we kind of just allowing to exist and like excluding anything within that path? Or what about certain processes that are allowed? Are we excluding any of those? And so what this does here is at the very top, we're creating a PS credential object using convert to secure string to convert a password and secure string, creating a PS credential object, and creating essentially a sim session so that we can connect to a remote system. And so that's what I'm doing right here. I'm connecting to a system. And then right here, what it's doing is get MP preference. I'm saying, okay, we're going to call that, but we're going to use a sim session and pass it into it. And so that will automatically pass whatever sim session I just created to a remote system. So it's already authenticating with the credentials I provided, and it already knows which system to connect to. Once we get that, we can see that there's some certain information allowed on this remote system. Like there's an exclusion extension of PDF. If it's a PDF there, just don't scan it at all. The exclusion path is the downloads folder. And in this case, the exclusion process is dolphin.exe apparently. So if you see that process running at all, just don't scan it, don't worry about it, it's allowed. So the next interesting commandlet that goes along with this is set MP preference. Set MP preference is what you would probably imagine. It allows you to set antivirus configuration settings for whatever system you're trying to authenticate to. The difference is there is set MP preference and there is add MP preference. Set MP preference will overwrite whatever settings currently exist for the system that you're targeting. Add MP preference appends to an existing configuration. So let's say, like on this previous slide, if PDF is here, and I were to do set MP preference to exe, the only thing that would be here now is exe. If I were to use add MP preference, you would see PDF and exe. So similar to get MP preference, you can just authenticate to a remote system using sim sessions. And so we're about to do a video, but basically, I thought this was going to be a little hard to see. What I'm running here is set MP preference. I'm using a sim session that I've already created to authenticate to a remote system. I'm saying, hey, set an exclusion path, which is the ctap directory, and set an exclusion extension, which is anything.exe on the system that I'm targeting. And so if you were to pull up Windows Defender on that remote system where you sent this to, you would actually see that information, like ctemp or exe is completely allowed. And right here is the command line example where if we were to run get MP preference, we can see, yes, that is actually allowed on the system. So believe, I'll have up in just a second. So set MP preference is kind of the same concept with attack surface reduction rules. You use get MP preference. You can get all the information about your normal AV configs, but you can also see if there are any attack surface reduction rules enabled. Well, you can use set MP preference to go ahead and stop them from spawning, or stop those rules from being enforced on a remote system. And the awesome thing about this is all of this can be done within constrained language mode. So if we look right here, up here at the very top is where you would see attack surface reduction rules when you run get MP preference. And so in this case, there is a specific rule. And Microsoft, of course, loves essentially GUIDs. So rather than being like WMIPSExec rule, it's this really long string. But then you can see with one being listed here, that rule is actually enabled. And so right now, the system that these rules are on, it will block and prevent any process being spawned that's spawned via WMI or PSExec. If we were to actually then run this set MP preference, we say, hey, this specific rule, which is that long GUID, and then for that rule, I want that to actually be disabled. This is what you would see at that point. You'd see a 0 instead of 1, and then that ASR rule is no longer running on that system. All right, so that was a lot here. I'll show a quick demo on what that actually looks like. Close this one. So what I'm doing here is we're typing get MP preference, and so we're going to pass it a sim session, which this was already created prior to this video being started. It's just using that sim session to authenticate to a remote system and pull back the antivirus configuration. As you can see, there's a lot of different information here. We can see at the top that an ASR rule is actually enabled, and that is the specific rule that blocks processes being spawned via WMI. And so that is active on that system. And so, well, I figured, let's test this, okay? So we're going to use PowerShell's invoke WMI method, the Win32 process class. We're going to tell it to create a process. And in this case, we're going to have it start or try to start notepad.exe. So that runs. And what you can see here is anytime you're using WMI, if something works, your return value should be 0. If it's not 0, then some sort of error happened. And this virus and threat protection, that's what pops up. So that actually prevented Notepad from being spawned right there, and that's it basically informing the user that it is not allowed because there's a rule set to prevent processes from WMI starting. So what I'm doing here now is I'm using set MP preference to, and I'm targeting this specific attack surface reduction rule, which is that long one, which is dealing with WMI and PSExec. And then I'm telling it for the rules, whether it's enabled, I want to actually go ahead and disable it. And I think I'm going to have to pass, yep, there's a sim session, so I'm going to tell it to use sim session. And so now it should be disabled. So if we do a get MP preference and repull the new configs, at this point, we can see if we scroll all the way to the top that those rules are now, that rule is now disabled. It's no longer allowed to run. Or it's not enforced is a better way to phrase it. So now if I try to use the same exact attack that I just did, use invoke WMI method, Win32 process, we're going to create a process. In this case, we're going to try to spawn Notepad again. What you can see now is this time the return value is 0. We actually got a process ID of what Notepad should be running in. And you'll see in just a second, because it's unfortunately off screen, there's Notepad. So Notepad actually was spawned, and it did work. And so everything that was just done here can be, you can do this within constrained language mode. So you can, as an attacker, if you see a system that is a high-value targeted system that has ASR rules enabled, well, as long as you have administrative rights over that system, you can just disable it. Like, you don't have to spend your time creating alerts. You can do quick recon and see if these rules are actually enabled, then just disable them and load your malware or whatever it is that you're wanting to run, or just run a simple command. And this is all allowed within constrained language mode. Again, because it's an administrative task. Oops, it's restarting it. So the next one.
Kind of cool question.
Yes,
So,
sir.
when we see GUI being referenced as opposed to, like you said, notepad.exe or something, where is somewhere in the one operating system that we can like kind of look up or reference that GUI to be able to make that translation?
Sorry, yeah, I should have brought that up. That was a great question. The question was if for different GUIDs that I was like just referencing in that, where can you actually find what GUID correlates to what rule? In this case, Microsoft actually did do a good job documenting this. So if you just do a Google search for Windows ASR rules, I think it's like the very first result that you're going to get actually has basically a table, and it says like this rule is for blocking processes spawned via WMI or PSExec, and then this is the GUID that's associated with that rule. So that they actually do have all of that documented.
Okay, I guess I was wondering if there was anything like inside the actual operating system as opposed to having to like go external, but if there's not. Cool.
Off the top, the question was, is there anything on the OS itself versus do you have to look at an external reference? There probably is a way. There might be a way to enumerate with that with PowerShell. I don't know that one. For me, I just do a quick Google search and find it out that way.
Fair enough. Thank you.
Yeah, no problem. Okay, so here's another different thing that we can do with get MP preference and set MP preference. So this is a little bit more fun. Okay, so in this case, I didn't show it on the last image, but here I'm validating and showing that I do have a sim session to a remote system, and I'm connected to it over DCOM. Again, all of this is allowed in constrained language mode. We're going to run get MP preference again on the system, and oops, sorry, that's not my mouse. Target it, and so we're going to pass the sim session in, And what you're going to see right here is that this extension is allowed in exe, and this exclusion path is also allowed ctemp. Well, what if I have malware that's in a PDF format, or if I want to drop malware or something in a specific folder? Then what do I do in that case? And so we just also showed the ASR rule is enabled. Well, set MP preference is our friend. I actually recorded this video for a separate conference, so you're going to see something related to this. But in this case, I'm using set MP preference. I'm passing in the sim session that I'm using, that I previously created. I'm going to change the exclusion extension, in this case to PDF. And because I'm using set MP preference, that should be overwritten. And so that will be there. And then what I'm going to do now again is get MP preference. We're going to try to pull back the information and actually see if it changed. So we just pulled it back again. And now we can see that we changed from exe to PDF. So you can just arbitrarily whitelist whatever file extension you want on a remote system to allow your code to run and not even be looked at by antivirus. In this case, we're going to also change the set MP preference. I believe we're going to change it to just a separate directory. From ctemp. And so yeah, we're passing the sim session again, and we're changing the exclusion path. In this case, I think I have like ctemp, it's like syncon or something like that. Yep, okay. And so we're setting that, and now we're going to use give MP preference. Oops, that's right, I'm going to have an error right here because I gave it the $. This is going to fail. I'll see that, and then we're going to try running get MP preference again. And we're going to pass in the sim session. And so now we can see that that file path is there. So here's a weird thing also that I've also asked other people. I haven't been able to completely figure out, and others haven't been able to understand either. So set MP preference, as I mentioned earlier, overwrites the value, right? Like we just changed from exe to PDF. Well, in this case, it just appended this, because we originally had ctemp, and now this has ctemp syncon. And I can't, unfortunately, explain that behavior, why for certain attributes it completely overwrites, which is what it's supposed to do, and then others, in this case, it's just appending an exclusion path. I have asked a few friends, and they don't know the answer either, so it's an oddity, it exists, and you should be aware of it, but as you can see, though, the path that we wanted to create was still created, and so we're now blocking or allowing anything from that path. Okay. So the bad news and the good news from a defensive side is, besides built-in commandlets, there's not a whole lot that's available for constrained language mode. I kind of like this because I think it's interesting. If anyone else starts really diving into constrained language mode, you can kind of be the people that really start building out capabilities. Like there's not a whole lot that exists. So I think it's kind of fun to get in there from the ground floor, start building out either libraries or different functionality that other people can use from a defensive, if it really helps, or an offensive perspective, where there just isn't a whole lot of code that exists. The interesting about this is any code that you write in constrained language mode will run in full language mode. But the inverse is obviously not always true. The other interesting thing is if you run it or write it in constrained language mode, if you go against a device guard protected system or now Windows Defender application control protected system, your code will run on it because PowerShell is going to be whitelisted. It's just running in constrained language mode. All right, so building out different capabilities in constrained language mode. There's largely two different methods of how to survive in a constrained language mode protected environment. One is to build a bypass for constrained language mode. I believe Matt Nelson has developed a couple different bypasses for constrained language mode. He's also done it for device guard itself, but for specifically constrained language mode or WDAC, he's done that. There's a couple guys, I believe out of MDSec, that have like just recently published a blog post on, I believe, using different COM objects or a specific COM object or something else that normally you would think should be blocked, but allows you to do something in constrained language mode bypassing its restrictions. The only thing with constrained language mode is it's going to have a limited shelf life, right? It's going to probably be serviced by Microsoft. and would not be allowed to run. But again, kind of like I mentioned before, constrained language mode is also really only effective if it's paired with application whitelisting, because if constrained language mode is enforced, like I mentioned, but application whitelisting isn't, then I would just not use PowerShell and write my own custom code. The other capability, or the other method to survive within a constrained language mode system is living off of the land, using what's currently available. So let's kind of explore these two options. And here I actually kind of just mentioned, I already talked about this, is constrained language mode needs to be really paired with application whitelisting. So one option to subvert constrained language mode is to develop a bypass. You can think of this as kind of similar to an exploit, but it's definitely not an exploit at all. But I like to think of it as you may have only one shot to use your bypass, because if I would consider it essentially burnt after that one time, because it may be detected by whatever defenders are on the system if they have the capability to detect what you actually ran. Now you can always hope that it wasn't caught, and maybe you can reuse that, but it's something that you want to make sure that you want to use it when you really need it. So Casey Smith has doing a lot of research on bypassing, largely application whitelisting. A lot of these things are for bypassing device guard and application whitelisting rules, such as msbuild, install util, and WMIC. But he also used cdb.exe, which is a debugger, which if you can, I believe he wrote a blog post about changing constrained language mode, or PowerShell was loaded in memory. He attached a debugger to it and modified something in memory within that PowerShell process to actually allow and like have it revert back to full language mode. So it wasn't actually enforcing constrained language mode anymore. So he wrote a bypass for it, and you can use these different capabilities. But again, it depends how the targeted system that you're going after is protecting their system. If they're using something like device guard, well, if your bypass is ever detected, they can update what they call their code integrity policy, or update their application whitelisting rules that they have to go ahead and just block whatever program you're abusing to bypass either device guard or constrained language mode itself. So this is a harder approach, I would say, because it takes a lot of time and it takes research. And so it's engineering time that your people are working on stuff to try to develop some sort of a bypass. You want to protect their use, but ideally it's a, quote, guaranteed win unless something else happens which is unforeseen to prevent it from working. The other option is to kind of live within the constraints of constrained language mode. Well, how do you kind of start this approach? And this is an approach that I take is, first of all, just deploy a VM of Windows 10 and force device guard on it, which is completely built into the OS, completely free. So anyone can just do this on a test VM to see how it looks, and then try to see and make sure that constrained language mode is enforced. And so you can just do a quick test by seeing what language mode are we in, try to do the square root of 9, something like that. After you have constrained language mode up and running on a system, the first step really is to figure out the problem that you're trying to solve. What do you want to do? So start small, use minimal tools, just write a minimal amount of code and test. And so when I kind of test building out things in constrained language mode, I kind of think of it as like a test-driven development process, because I'm writing a couple lines and then I'm testing to make sure I'm getting the expected results and not any errors at that point. If I'm getting like this is blocked and only allowed in full language mode, then I know I need to go back and rewrite something that I'm doing. So this is exactly, next slide is basically what I just said. Write a small amount of code that starts to solve your problem and test to see if it actually does solve that problem. As you encounter different invalid operations or you're using restricted data types, look to see how you can modify your code that you're using to come up with a different way to do it. And so I'll talk about how we do that in just a second with WMImplant. The big thing to go into this is writing in constrained language mode. It's going to be a frustrating experience because everything that you're used to doing and being able to leverage with PowerShell is probably going to be blocked. And so you have to try to figure out different ways to do it. And this is very much like your typical hacker mindset, right? Like if something doesn't work the first time, you're not giving up. You're going to keep going and look for a different way to try to solve whatever problem it is or line of code that you're doing. Again, don't look to C# code within your PowerShell scripts. It's probably going to be blocked. Look to recreate the same end result, if you will, that you expect from C# within PowerShell. So what currently exists, and what's an example that we can reference? So WMImplant. So this WMImplant is a tool that I wrote that is 100% written in to be compliant with constrained language mode. I can't remember how many lines of code this is. Probably like 1,500 lines, which really isn't that much, but spending that much time slamming your head against a desk trying to deal with constrained language mode blocking everything you're doing is an interesting development process. I built this to target device guard protected systems. And this was because I wanted to, as I'm assuming more people are going to eventually start rolling out application whitelisting, I want to have some sort of tooling that will let me attack them. Well, device guard enforces constrained language mode, so I had to write a tool that worked in constrained language mode. WMImplant uses both PowerShell and WMI. Both of these binaries and/or services are going to essentially always be allowed to run on a system, even a system that's that's enforcing application whitelisting. I have personally never seen an environment that blocks completely outright PowerShell.exe. Even if you did, like I mentioned earlier, you can just load the DLL in the back end and just gain access to PowerShell again. With WMI, I've never seen an environment that prevents WMI from running. I have seen environments that maybe block it from one network to another network, but WMI is commonly used by administrators to test the strength or the health of systems, gather different information. So that's generally always allowed. So I use WMI for C2, the means to trigger an action, and data storage. Well, data storage and encoding were problems, but I was able to figure out how to make this work in constrained language mode. So like I mentioned earlier, one thing that we cannot do in constrained language mode is, unfortunately, convert to a base 64 string. Because if I want to download or upload a file, when I do this, I can't generally always deal with binary data. It has to be encoded in one format or another. So this just outright doesn't work. If I want to download a file, I can't convert into base 64 string. So I'm trying to figure out, okay, how do I encode data in a format that does work in constrained language mode? So I was actually talking with my coworker at the time and my friend Daniel Buchanan. He wrote the awesome tools, invoke obfuscation, invoke, a couple different ones that makes PowerShell look disgusting. So I would definitely say to go look at that. But what this lines does is, so this is a test data. What this does, this just says this is just sampled data. It's just a random string. And what this kind of like one-liner here essentially does is it takes either a character array or a byte array, depending if you're dealing with text or binary data, and it converts each character or a byte into an integer. And it then does that in a comma-separated one line. So this string, this is just sampled data, is converted now into this. So we see 84, comma, 104, comma, 105, comma, 115, and so forth. This is perfect. Like, this is all that I actually need. And this completely works in constrained language mode. So while it's not base 64 encoded, we're just going byte by byte or character by character, converting into an integer, and that will solve our encoding problem. So all of our data is now encoded. Next thing, so old dog, new trick. So I kind of wanted to try to solve the encoding problem, specifically the base 64 encoding problem. But the thing is, obviously it doesn't work at all in constrained language mode. So I needed to figure out where is the restriction in constrained language mode, what's preventing it from happening, and this is where I was like, okay, let's, I guess, figure out how constrained base 64 encoding actually works. So does anyone here know how base 64 encoding works? Awesome. If you want to snag something, you can go ahead and grab something. So we're all going to learn right here. Basically what it is there's 64 different values that your character can be, and I'll show how to determine it. Once you find a number, if the value is 9, then your character that you're using is J. So the way that works is you go let's say you have a massive string of bytes. It's not a string of bytes, but just a long list of bytes. You take 3 bytes at a time, so that's 24 bits, and you split those 24 bits into 6-bit chunks. So you end up with 4 6-bit chunks. Then what you do is you take each of those 6 bits and you look up whatever that value is. And so that's your base64 encoded string. So I know that's kind of abstract. Here's an example. So let's say we're trying to base64 encode the string man, capital M, lowercase a, lowercase n. And this is taken straight from Wikipedia. Well, this is what man is, the byte. And so here's our 8 bits. Here's lowercase a, and here's lowercase n. Well, if we split this up into 6-bit chunks, we end up with this is the first 6, this is the next 6, and so forth. So this in binary is equal to 19. If we go back to that table and find 19, that is equal to capital T. And so that's how we can figure out what that first value is. Same process for the rest of these. This is 22, 5, 46. So if we just go back and look at 46, we should see right there is lowercase u. So there's a known associated alphabet with what every single value should be. So same process, the next question would be, well, what if like we only have one letter left and like the rest is just blank? So in this case, you normally would just pad these out to zeros. And in the case where there are no extra letters, that's where you get equal signs. And that's how they pad it out to make sure it always has 64 bits. Or excuse me, 24. So if we use Python 3 and we try to figure out, okay, what does man actually look like? Again, we can see this is TWFU. And that's our value. So I then try to figure out, okay, how can we do this in constrained language mode? And so I wrote this script called PowerShell, or it's called CLM Base64. And after taking a lot of time working on it, it was able to figure out how to get Base64 encoding working. I'm sorry this is kind of dark. I'll push these slides online so that you guys can look at these and see these a little bit easier later. But what this is doing is basically it can take either a string or a file as input, and it will go through and perform this Base64 encoding process. The other interesting thing that it does, which I'll have in a later slide just to show, is you can provide what's called an alternate alphabet. So when we're dealing with Base64, according to the RFC, this is the standard alphabet. This is 0 is always equal to A, 1 is always equal to B. Well, what malware authors like to do sometimes is they, of course, like to make life harder for malware analysts. What's this prevent you from just swapping capital, like inverting this whole alphabet and making 0 equal to a slash, 1 equal to a plus? You can just arbitrarily assign a different alphabet to what each value should be in Base64. Well, this can sometimes mess up automated analysis tools. So what this library does is it also allows you, or this command line does, it does allow you to provide an alternate alphabet if you want for Base64 encoding, and then it will validate that it's a valid alphabet, and then you can just start using that. So this is where we're going through. We're doing checks, like if the value is not equal to 0000000, then figure out what that binary value is. So like if it's not 0, and which is A, then figure out, look up in this chart, which is stored in the script, what is the value of whatever the number is. So I'm doing right here. Otherwise, just assume it's A unless we provide an alternate alphabet. This is kind of at the very end where it's looking into padding. So I didn't want to go over this line by line, just wanted to give kind of examples out of this. How it works is here it's checking, is there any equal signs that we need to include in padding, or if we're decoding, to remove before we actually go through and get the actual content that we were trying to get. So here's where I ran into a problem with Base64 encoding is, as you could tell earlier, we have to figure out what the base 10 value is of some binary number to then figure out what that value is in the Base64 encoded RFC. But that is actually blocked. You can't actually convert 111111 from base 2 into base 10 in PowerShell constrained language mode. It's just not allowed. So I was again actually talking with Daniel Bohannon about this, and I think before I even finished explaining my problem, like, hey, I just ran into this like weird issue, like I'm gonna try to solve it. He's like, I figured it out. And so he's like, here, I got this one-liner, look, it's just this real quick thing. And I was like, well, that's awesome, you just totally did this and figured out how to convert this from base 2 to base 10. Like we now had that functionality. So this was one of the bigger hangups originally, and it can now just easily be done with this PowerShell one-liner right here, where we have the different powers of each spot and then just going through and getting that data and converting it. So just as a quick example here, using this script that I wrote, Host run space language mode. You can see we're in constrained language mode. We're going to convert to base64 string with the string man. We still get our TWFU. If we convert from base64, that string, we get back our man value. So we have base64 encoding now completely working in constrained language mode. And this is, again, where I was talking about at the very end, just how to do an alternate alphabet. And it's in there. We're running short on time, so I'm going to see if I can do a quick snippet of this video, and then we will stop right after that, which is the end anyways. So it's 50 seconds. So here you can see we're just going to be running host run space. We are in constrained language mode. I already have, I'm going to test, okay, here. We're going to try doing the square root to figure out if constrained language mode actually is enforced, which we will see that this is an error. And so now I believe the next step is going to be, okay, we're going to try to convert to base64, and we're going to put some sort of string here. In this case, again, we're going to look like 40 north and BSidesAugusta. And we're going to let it run, and we get that value coming out of it. So it actually did encode that data into base64 format, and now we're going to convert from base64 back into trying to find the original string. Well, easy way to do that, let's just copy and paste that encoded value in, put it in there as kind of off the screen, let it run, and then we got our results back. So that's largely it. This capability didn't exist in PowerShell constrained language mode at all before. It's not a hard problem to solve. Like, it's super basic, but I wanted to be able to figure out how to just encode data that you couldn't normally do before. So in Microsoft's own words, like CLM is designed to support day-to-day administrative tasks. Even though there's a lot of things that are restricted, there are still a lot of things you can do. Largely from an attacker's perspective, I want to be prepared for that environment and have certain capabilities, then don't have those capabilities and just be in trouble. An attacker will look to use your administrative tools as a means to enable their goals. So like just how we could do modify antivirus and everything like that, an attacker's going to look to do the same thing. So when you see that, enable your telemetry so you can start catching what they're doing as they do it, and so you can have at least the ability to reconstruct the attacks that they performed. That's really it at this point. I literally just before this talk pushed the code and made it live, so it is now available on GitHub. You can go check it out if it's of any interest. The next thing that I'm looking to do is start adding encryption into this, where there's no ability to just encrypt data at all in constrained language mode that I know of at this point. So that's the next thing I want to build out and have available. But if you have any questions, we can talk now. I know we're really short on time. We can also talk on the side. Or you can hit me up on Twitter, go to our website, anything like that, and I'm happy to discuss anything that there is. So I'll take questions if I can. Otherwise, thank you, everyone, for your time. Yes, sir.
Quick question. The constrained language mode only impacts the current PowerShell or PowerShell session. It doesn't impact the .NET framework underneath. You can still run PS attack on the system, right?
Probably not, because if you're running that through PowerShell and it's using any sort of non-listed data type, it would not run. The question was, can you still run something like PS attack or other C# through PowerShell on there? And if it's enforced on there and it uses a non-whitelisted data type, it will probably be blocked. Any other questions? All right, thank you. Thank you very much.